So we are recording. So Martin manually assigned a couple of 3 people to a meeting room. So if you were one of those and you got assigned to the wrong one, then I think leave, and we'll try to reassign you to the other one or something.
Yeah.
But hopefully everyone's where they want to be now. Also, as I said, we want someone to make some notes and do the summary at the end. Martin offered to do that, but if anyone else would be willing to do it, that would be great. So speak up now if you'd like to do that.
Also, aside of me, if you feel that you want to make some notes, but you don't want to be the main person to do the notes, feel free also to make your points, and then after the breakout room, we can hear your thoughts.
Okay. So hopefully you're all seeing my screen now. So I've got a few slides to help drive this along, but as I mentioned, we really don't want this to be a presentation or a lecture or whatever. This really does need to have audience participation, and some of the questions I'm asking I don't know the answers to, and I'm rather hoping that some of the people here do. So what, as I said earlier, this is what I think we should cover. Why is it important? Describe some common anti-patterns. Look at alternative build tools that solve some of those anti-patterns, and finish off with container image scanning. So the first one I think is very quick and very obvious. And I assume most people are familiar with Docker container images and know about this. But for me, there seems there are 3 obvious answers why we want to build small container images. The obvious one is that they're small, so they take up less storage. Although that's not sort of a massive problem, if you are heavily containerized and have lots of containers, they can fill up quite a bit of space. But that's I'd say a relatively mild reason for doing it. A more serious reason, obviously, is that in the containerized world, you're frequently pulling the images across the network, and sometimes repeatedly. And the bigger the image, the slower it pulls. So that's sort of a real reason for doing it. But the biggest reason really for having small container images that I see is that you have a smaller attack surface. Every bit of software you have in your container is a potential backdoor for a hacker to get in and do some harm. So the less you have in the container, the less opportunity there is for attack. So I don't think I'll dwell on this anymore, but are there any other advantages people know of, or any other views on this? No. Okay, let's move on then. So now it's a spot the anti-pattern. So I'm assuming everyone's familiar with the Docker file and will understand what's involved here. So what's the anti-pattern here?
Yeah, well, I would say that the anti-pattern is that you don't log to a image version. That would be the main one. It's latest by default, but then when the latest updates, your image won't pull.
Yep, absolutely. So no tag was specified. And what that means is the underlying image will change over time. So you're going to have an unpredictable build. What follows on from may longer work if the image has changed a lot. And another sort of what I thought was an anti-pattern is I've always used Debian images rather than Ubuntu because they used to be smaller. And there seemed to be a better base image. But when I looked at this the other day, actually there isn't much difference in size between Debian and Ubuntu. Maybe that's something to keep an eye on. But clearly you don't want a big, fully functional container as your base image. You want a lightweight one, and obviously there are some very lightweight images such as Alpine and the like. So choose a small base container, base image, not a big one. So okay, we specified the tag name now, so that's an improvement. There's still an anti-pattern here, and that's the Bionic is an old Ubuntu release. So it may lack the latest security patches. And even if you do a sort of apt-get update to update the packages, that will add a big layer to the container. So your image is already getting bigger than it should be. If you went for a more recent, in this case Ubuntu release, you would have those security patches built in to the base image. And even if you do an apt-get update, that will add a much smaller layer.
Yeah.
So that's.
I would maybe add here that whenever you do apt-get update, it's always useful to clean the cache from apt-get in the same layer whenever you do update.
We're coming on to that one. So here's one. I'm sure everyone knows this one. So I won't put that to the audience. So we all know this. This is the layers in the Docker file issue. Each of these commands creates a new layer, and layers can only get bigger. They can't get smaller. So here we are doing what Marcin is suggesting. We're doing a clean at the end to clean up the stuff that's no longer needed. But actually that clean, it will remove those files from the image, but it won't make the image any smaller. And so there are two things. Firstly, doing it as 3 different steps is bad. And secondly, this install is actually, can be made leaner, as we'll see here in the solutions. This is how that should look. As a single command, you sort of pipe, well, no, it's not a pipe. You run the commands in succession. You do that one and do that one. So you do a yum update, yum install your package, nginx in this case, and then these flags here basically tell yum, the install weak dependencies. False means don't install packages that are sometimes useful but are not essential to the functioning of the package you are installing. This one says don't install the documentation. You want to run a container. You're not wanting to look at the documentation, so don't install it. And this one says don't install. Only install the language pack for US English. So yeah, sorry, your application may not be visible in French or whatever, but that's probably not a problem. And then at the end, clean, and that's all run as a single step in the Docker build, and so it's a single layer. And so the clean does have an effect now. So here's another one, and this is something that I do very often. It's very useful, and I've seen a lot of Docker files that do this sort of things, but it's really ugly, really not a good approach. And again, fairly obviously why. The resulting image contains the entire build infrastructure. So it's got to contain Git, because we're doing a Git clone. It's got to include make and probably GCC and all of that stuff that is being built. So yeah, you build your application, but the container is left with a lot of unnecessary packages that were needed there to build the application, not to run it. So again, any comments on that?
I actually don't know what would be the solution to that.
Okay, well, we'll see that. We'll see this.
Presumably the solution is to copy whatever's built into a new image and do it as a multi-step build.
Yeah,
but I guess we'll find out.
Yeah, that's going to be one of the solutions. Yes, but I think there are several solutions to it. So again, here I'm sure everyone knows this. It's not a good idea to run your containers as root because it's a security risk. But this one's there's a little more subtlety to this one than just don't run containers as root. Firstly, if you don't put any user command in your Docker file, you might well be running as root because your base container is running as root, and you need to remember to switch to the user that you want. So you should really always think of wanting to have a user command in there, probably as pretty well your last command in the Docker file, just to make sure you're running as the user you want. But slightly more than that, it's good practice to try to have the container, to allow the container to run as an arbitrary user ID, where, for instance, the Red Hat's OpenShift does this by default, where its preferred option is it decides what user ID the container runs as. You don't. That means it is more secure because you have proper isolation on the host. You don't have two processes running as the same user ID on the host. But your container needs to be able to run as an arbitrary user ID. So if you build a container, if you build your own container, can it run as user ID 345672? Well, ideally it should do. And another gotcha here, this user root or whatever, let's say my user or whatever, is not a good way is not good to do. Better to use the numeric user IDs, because the container runtime environment will actually know whether that's root or not, because the ID is 0. Just with a name, the runtime environment doesn't know necessarily what that name is. So when you switch to a user, preferably switch to the numeric ID, not the name.
I have a question. I have a question to that.
Yep.
So if you use 0, is root 0 as well on the normal host machine?
Yes. That's the risk. If you have a security breach and something in your container breaks out onto the host, it is running on the host as root. And that's the risk.
Mm-hmm.
It shouldn't happen, but if there's a security hole there, then it can happen. And so this one, just in case you were wondering, this is exactly the same command that I put on a few slides ago as the solution to the problem, but it's still an anti-pattern. And what's the anti-pattern here? It's a little more subtle, this one.
I can't see it. I would write it like that, to be honest.
Yeah. Well, you would, but writing it like that means that your resulting container image contains yum. It has to, because you're using yum. And what that means, and it's worse than that, because what's yum written in? It's written in Python. So you need Python. But you're building a container that wants to run Nginx. You don't need yum to run Nginx. You don't need Python to run Nginx. But it's there because of the way you put Nginx into the container. So really, using yum or apt or whatever your package manager is not good if you want to build the smallest possible containers. And there are ways of avoiding that, which we're going to come on to now. So the solution to that is some alternative build strategies that we'll quickly touch on. But before we move on to this, anti-patterns, I'm not trying to be complete here. I'm sure there are hundreds more, and I'm sure that people are a lot more knowledgeable about it than me. But anyone here want to raise any other biggies that I've missed off?
Actually, I was going to say, you're using things like Ubuntu Debian because you want to make small, secure containers. Don't use Docker a lot, but I'm sure, aren't there already other operating systems you can use, other Linux ones, which are already small and secure?
Yes, of course there are. There are particular types of containers that operating systems that have been designed to be lightweight containers, such as Alpine and things. Ah. So yeah, it can be good to use those. The problem with Alpine is it has so little stuff that can be a problem. And I think it doesn't have the glibc libraries. It has a lightweight version, so some things won't run on it, or something like that. So you can be caught by trying to get too lean here. Okay, let's move on. I'm just checking how much time we've got left. Yes, we've probably got about, I think I'll make it about 12 minutes left. So we do need to move on. So the alternatives, multi-stage Docker builds, and then 2 alternative build tools, one from Google and one from Red Hat. So multi-stage Docker builds, I imagine most people are familiar with this now. It's been around since Docker 1705, if I've got my facts right there, but I still don't see it being used very often. I don't use it very often, and I should. And the approach, I'll explain the approach just in case people are not familiar with it. So you can set up your Docker file to run in multiple stages. So this top bit is a build, and it's a heavyweight build because it's got, you know, the Go machinery, the Golang machinery in there to build your application and things. And then you have a second phase of the build that basically the important command here is this copy one. And what this does is copy something from the top build into the container of the second build. So the top one's heavyweight, the bottom one's lightweight, and just copies the files across. So that's that's one way of avoiding many of those anti-patterns that I mentioned earlier. Has anyone got a lot of experience with using multi-stage Docker files? Any comments, any problems they've found?
I have actually 0 experience. I didn't know you could do that. And can you explain it one more time? So if you have Docker file like that, does that mean that the final image will be on the Alpine and the Golang is basically just gone?
Yes. It's an Alpine image. You use the package manager to add CA certificates, and then you copy your Golang executable that you built in the top one. Remember, Golang applications are statically compiled binaries. There's just a single file that is your application. You copy that file into your Alpine container and then run it.
And how do you define where it's copied? That dot, it's in that work there? href counter?
It's this copy command from 0, which means from the first container, the previous one.
Mm-hmm.
Copy that file, which is what was built by the Go compiler, and copy it into. Mm-hmm. So it'll be /root/app. And then you just run that as the command.
Wow, that's actually amazing. I have never seen it before working like that. I didn't know you could do that. Awesome.
Okay, any other comments on that? Okay, so the next one is this is defining the problem. There are problems with using Docker, and it's primarily around the Docker daemon. As I'm sure we all know, this is a big fat binary that runs as root on your host machine. And because of its sort of client-server architecture, what it means is that if something has to run as root, then everything has to run as root. So things like creating networks needs root access, so the daemon has to run as root. So even simple things like doing a file copy have to run as root. So that's one problem. There's the security issue around that, and why some sysadmins are not willing to run Docker. Secondly, the Docker daemon is not always available. So for instance, by default inside a Kubernetes cluster, there isn't a Docker daemon accessible within the cluster. So a pod can't access a Docker daemon unless you jump through hoops. And that's what these alternative build tools that don't need a Docker daemon have been primarily designed for. But even using Docker with Docker is tricky. There are solutions like Docker in Docker, which means running a Docker daemon within the Docker container, and what I call Docker alongside Docker, where you mount the Docker socket into the container, so that you're actually accessing the Docker daemon on the host. So there are solutions to that, but they're ugly and they're not nice. And at the end of the day, a container image is actually just a collection of files, the layers, packaged up as a tarball and an associated JSON file that provides the metadata. Now, hang on, creating some files, tarring them up and creating a JSON file really can't be that hard. You shouldn't need a big fat daemon to do all that. And that's where these alternative tools come in, Kaniko and Builder, which allow you to build container images without needing to access a Docker daemon. So the first one, Kaniko. I've not used this. I've got no experience. It's what Google have created. A primary purpose is to be able to build containers within Kubernetes. I'll put some links here and just read that description if you want to, because it describes what it does. Has anyone used Kaniko? No. Okay, that's a shame. I'm hoping someone would have some experience with that. So let's move on. Builder is the other one. This is Red Hat's tool, and it can do the same thing. It can build a Docker file, build an image from a Docker file using the builder bud command, build using Docker file. So you can use it just like the Docker build. It's like exactly it's builder bud dot instead of Docker build dot. But that isn't the only way you can build it. You can build images. You can build them just using bash, because all you're doing is putting files into a layer and creating a tarball. Builder can as I'll show you some examples. Builder can do that without a Docker file. There's no Docker daemon involved again, and it allows you to build images, container images that only contain what you need at runtime. All the build infrastructure is not there. But you can still use your package manager to achieve that. But the package manager does not get included in the final image. So there's a link here to how's this go? Link there to the builder. We'll circulate these slides. There's a link there to the Builder website if you want information on it. I did a blog on this. It was about 2.5 years ago on using Builder. So that's quite. If you want more information, just read that blog post. And what I've done in the last couple of days is just updated the contents of that. So I've got this GitHub repo here that actually is sort of slightly more modern version of what's described in that blog post. So how to create an environment where you can run Builder. Look at the basic images. These are the Docker Hub ones. I don't think we've got time to go over this in detail. That's how you would build an Nginx container with Docker. So Docker build dot. Now, this is how you can do exactly the same thing with Builder. So builder bud dot, and you end up with what is effectively exactly the same container image as if you'd built it with Docker. More interesting is building it with a shell script. So if here's one that just builds a very basic CentOS image. So what this we'll look at this in a minute, and then an associated one that really does exactly the same thing but also installs Nginx. So actually, let's look at that script and run through it quickly. So this is what a Builder script looks like. Builder from scratch, which means build a minimal image that really just contains the Linux kernel. Mount it, so you've got access to the file system where the images are going to end up. Do a yum install of the packages you want. We put very little in there. We put bash because we want to be able to shell into our container and debug things. We put in core utils, which provide some basic debugging and utilities, and we put in Nginx. And we say where we want to install them, those packages into, and we install them into that mounted file system, which is going to be our new container image. So blah, 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 blah. Then we add some labels to the image. This is adding the metadata. We define the command. then we unmount the container, and then we commit the container. So a relatively simple thing like that. It's really no more complex than a Docker file. You can build a container, and what this container contains is the basic Linux kernel. It contains bash, core utils, and nginx, and the command to run the container. Nothing else. It doesn't contain yum. We used yum to create it, but the image we create doesn't contain yum. So it doesn't contain Python either and all that thing. So that ends up being a lot smaller. Okay, we've got 2 minutes to go, so I won't dwell on this anymore, but the minimal CentOS image that we build with that is 56 meg, compared with the one on Docker Hub that is 204 meg. So a big difference. So we haven't really got time to discuss anymore because we've still got a bit more to go on with. This is image vulnerability scanning. So you've probably seen this on container registries such as Docker Hub or key.io and things. And on Docker, there's this tempting little button called enable when you look at the images you've pushed to Docker Hub. Click on it, and unfortunately, Docker are asking you to get your credit card out. But if you did get your credit card out, you would have Docker would run the vulnerability scans and give you a report and things like that. Very useful, and other repos also have similar things. But what I was doing is actually seeing what public tools are available here. And there are a few. So I'm just checking with Sandro. He's giving us a few more minutes, so you don't have to rush quite as much. So there are a number of reviews I found that summarize the situation. But the two most promising ones seem to be Anchor and Claire. Claire is the one that's used by Red Hat on their key.io container registry. So it's presumably going to be very robust and well maintained. Anchor I'm less familiar with, but it looks like a very good tool to use. So before we finish, I'm just asking Sandro for 5 minutes so we can go on. Who's got some experience with either using the information that's provided by the container registries, or of using any of these open source tools to do your own scanning?
Well, I haven't used these ones, but I know that my company previously used, like, GCP have their own vulnerability scanning. But in my experience, most people, we just ignore a lot of it. There's a lot of warnings pop up, and you just told ignore them, move on. Maybe a few errors, and that's it. Maybe have a quick look, but mostly ignored.
Okay, that's interesting. So you found them not useful because of the amount of noise they
I think that's it's a lot of noise comes through. I mean, I'm sure it should be useful and people should take care of it, but I'm finding my own experience with a couple of places is they normally just move on from them, just ignore it. Turn it on to get the information. We used to have, I remember adding to a pipeline where it would fail the build if there was more than X number of vulnerabilities, but that happened all the time. So we never got a proper build. So it's just put it as a informational only.
But isn't the severity of the warnings probably more important than the number? So here,
So I mean, so there would be, I don't remember the levels we had. This is a few years ago now, but a certain number of the higher level warnings, severe. So I suppose it'd be informational, severe, etc. Yeah, go from that.
One thing I've seen in the past, which doesn't involve vulnerability scanning, is just automated rebuilds of all your containers once a week. So if you're using, say, Yum packages or Debian packages in your container, then the rebuild should just pick up the latest at the time of build, and then you can just redeploy with the updated packages.
Yeah.
If this changes.
Yeah, I think that's a good approach. Yeah, it's not good to have your still be using containers that were built based on an image that was around 2 years ago. Okay, any other experiences or any thoughts on this? Okay. Any final thoughts before we go back? Any comments for Marcin to summarize?
I guess I've got one thought, which is if all your installs are doing yum updates, then yum install and cleaning out the yum cache every time, then presumably that means you're going to have a loss of traffic just re-downloading all the yum package information if you're not careful. So has anyone given any thoughts to, say, local mirrors of yum and building packages that use those?
Well, you're clearing the cache out of the container image you're building, and next time you build a new container image, you'll be doing exactly the same thing. I don't think there's any what's the right way to phrase this? The caching doesn't help when you build the next container because you've got no cache when you start with. Don't know if that makes sense.
No, that makes sense. I think in my case, I was thinking more if you were, say, doing multiple steps that had to install packages, but
yeah.
The point about it having a local mirror probably helps more when you've got multiple packages that you're building because you're not pulling from the internet every time for every single container.
Yeah.
If that makes sense.
Yeah. Okay. Sandro's about to close the room, I think. So
yeah,
be prepared to be kicked out.
Yeah, I have a quick question regarding the vulnerability scanning. Does it actually scan against like malicious containers? Like when you download it from Docker Hub and it contains some malicious code, does the vulnerability scanning takes that in consideration, or it's just the packages?
No, I think it's a static analysis of the container image, and I think there are a number of rules that it looks for. Most of it's based on the CVE knowledge base. I don't really know how it does. It must be looking for certain things, certain versions of packages, certain things like that. So I don't understand in detail how it works.
And have you heard if there is anything about something that would prevent you to download the malicious containers? Is there anything like that?
No, I'm not sure aware of anything that will prevent it, but the common approach that big companies do is to create their own container repo and only allow things into their container repo if it scans successfully. So repos like Harbor or JFrog's Artifactory. That's what we work with people who take that approach. So they're only pulling images into their container registry that they know that they've already scanned and are relatively safe.
Okay.
Yeah. Okay, we're in a 1 minute countdown now, so I guess we might as well leave and rejoin the main room.
Yeah.
Thanks, everyone.
See you soon.